Hey guys, this is Gabino once again, and here this is just an extension of where we left. So remember in the previous video we were talking about addition and subtraction with surds, right? Addition and subtraction of surds, right? So remember we said that addition and subtraction of surds operate the same way as addition and subtraction in algebra, right? So there's no difference. However, the only thing that you have to do here is the rules are, the first thing that you do is to write the expression or the set that you're given in the simplest form. Once you have finished that, the second part is to actually collect like terms or like surds. And once you have done that, then you can go ahead and add or subtract them the way you want because they're already in the same format, right? So with this example, let's apply the same rules here and see how it goes. However, before this, remember in the previous video we talked about how to simplify a set, and what we said is to simplify a set, where you take the number under the set, you divide it into two numbers, one being the highest perfect square, and then you can go ahead with using the perfect square that you have to simplify it. So let's apply those rules again to see how we can get this one done. So here what we have 5 square root of 75 minus 6 square root of 12 plus 2 square root of 8 plus 4 square root of 3, right? So look, this is not the simplest form, right? We can simplify this, we can simplify this, we can simplify this. So we have the first step one. So let's get step one. Step one, simplifying surd, right? So we're gonna actually write them in the simplest form. The simplest form. So here what you have is we have equal, and then here notice that this could be written as 5 times by the highest perfect square that could divide 75 is 25, right? So we're gonna have 25 times by square root of 5, because we know that it can be 5, we have to be 3, because we know that 25 times 3 is 75. So we are not changing anything here, we're just breaking it down into two parts, one being the highest perfect square. And then if we do the same here, we have 6 times the highest perfect square that could divide 12 is 4, right? So we're gonna have 4 times 3, and then the next one we have 2, but then 8. How do you simplify 8? Same rules. Highest perfect square is 4, so I have 4 times 2, so this is 4, and this has to be square root of 2 plus sorry guys, plus 4 square root of 3, huh? So now this is the simple. I'm trying to simplify this, try this in the simplest form. So my next line, let me get rid of the brackets because they can play a vital role in this. Explain properly the brackets. So here we have 5 times square root of 25 times square root of 3 minus. Now when we explain this, right, so remember, before we do this, right, remember, so this is multiplication, right? Everything here is just multiplication. What we can then do is we can simplify this, right? We can simplify this. We can go ahead and simplify this because we know that square root of 4 is 2, right? Square root of 4 is 2. So what I could do here, I could have actually I'm gonna keep the brackets. Sorry guys. So we're gonna have 4 times 2 times 2, and then here we're just gonna have square root of 3, and then here plus 4, we know again is square root of 2, so we're gonna have 2, and then here we are going to have 2 times 2 square root of 2, and then here don't forget the fact that we have below here, so it's 4 square root of 3. Now my next line here, so realize that in here we didn't do much, so let's simplify this as well. So this is just 5 times 5 square root of 3 minus, so what is 6 times 2? 12, right? So I'm gonna have 12 cubed, and then here plus 2 times 2 is 4. 4 root 2 square root of 3 plus 4 square root of 3. Right. So here we are getting there. We're getting there. Now we realize that we have got some lucky surds. Lucky surds. I've got some lucky surds. Which is our step 2. Step 2 is remember, step 2 is to collect the like surds. Right? Collect the like surds. So here we are going to have 25 square root of 3 minus 12 square root of 3 plus 4 square root of 3 plus 4 square root of 2. Right. Now, what is 25 minus 12? Right? 25 minus 12, 13, right? 25 minus 12 is 13, and 13 plus 4 is 17. So we're going to have 17. Going to have 17 square root of 3, 17 is square root of 3, and then plus 4 root of 2, right? So I hope this makes sense, right? I hope this makes sense. So remember, the first step, write the surd or the expression that you have in the simplest form, and the second step is to collect the like terms or like surds. And that's what we did here. So what we did is we simplify 70 for square root of 75 first, because we know that to simplify a surd, you have to find two factors, or you have to divide the number under surd into two parts, or into two numbers or two parts. One being the highest perfect square, and the highest perfect square for 75 was 25. And here the highest perfect square in 12 that could divide 12 is 4. And the same here, the highest perfect square that could divide 8 is 4. So we did that, and after that, the next line was just to evaluate the square root, right? So we did that, and the next line we get rid of the brackets, which we did, and then the next step or the final step was to actually get rid of collected the lactans or lactans, which we did, and this is our final solution. Thank you so much, guys. However, I promise you that in the next video we'll start division, multiplication and division of surds, right? Multiplication and division of surds. So let's do multiplication, and then surd will be in the next video. Thank you, guys. Multiplication and division of surd, right? Multiplication and division of surd. So we have got one of the rules that we'll be using in this example, in this tutorial, is square root of a times the square root of b is the same as square root of the product of a and b, the square root of the product of a and b, which is the same as b times square root of b times square root of a. Why? Because multiplication is commutative. Multiplication is commutative, right? Commutativity basically saying a times b is the same as b times a, right? We are not changing the value, we just swapping the position, all right? So this is very important rule that we'll be using, and there is another extended version of this, right? So let's start with this. Okay, so what could be our examples, right? Let's see what could be our examples. We could say that a is let's say square root of 12 times the square root of 3, right? So this is our a and this is our b. What we just said is just the product of those two. So this is the same as square root of 12 times 3, right? Which is the same as square root of 36. Is this our final answer? No, I wouldn't leave this. Honestly. Even though they didn't ask me to simplify, I wouldn't do this. So what you can do is you can simplify this. We have seen how to simplify. To simplify, I said you have to divide this number into two parts, one being the highest perfect square. So what is the highest perfect square in here? Oh yeah, it's 36. Right? 36 is always the highest perfect square of itself, right? So 36 is a perfect square, which basically means it's 6 squared, which is just 6 squared, and then Just the answer is just 6, right? So you can see where this leads, right? Depending on the number that you have of a and b, you could end up with an integer, right, or natural number. So yeah, remember this rule will be vital. Now we just look at that. Let's look at the extended version of that rule. The extended version of that is when you have c times a times c square root of a times d square root of b equals to cd times the square root of a times b, right? So let's say that we have, for a, we're gonna use the same number, but then this time we'll have, let's say we have 2, let's say we have negative 2 square root of 12 times 5 square root of 3. So our rule says that you take a times c times d, which is basically c times d. So this is our c and this is our d. So c times d, we have negative 2 times 5, and then what you have is square root of 12 times 3. 12 times 3, right? 12 times 3. So, and the next line, what I'm gonna do when you evaluate this is you get negative 10, and then here you have 36. We just do 36 here. We saw that the final product or the final answer for this one, square root of 12 times square root of 3, is 6, right? So basically that could just be our final answer. Will have negative 10 times 6, which is negative 60. So guys, this is the answer for this question. However, remember, multiplication and division of said operate the same way as the prenumerals for algebra, right? So what you do basically is you simplify them if you can. However, you can simplify them if you can beforehand, or you can just apply this rule, taking whatever you have under square root times it, and then the product, and try to simplify the product. But depending on the numbers that you have got, sometimes it's easy to simplify this first before you could even evaluate this, right? So for instance, this is 12, right? What I could have done differently, what I can do differently is I could have done this. I could have done this. I could have done this, because we know that 12, if you divide 12, the highest perfect square, and 12 is 4, right? You'd have square root of 4 times square root of 3 times square root of 3, right? Which will give me square root of, which will give me square root of 4 is just 2, and then when you have square root times itself, so just 3, or alternatively what you could write is 3 squared, because you just times these numbers. So here you realize that this is our a, this is acts like b, and then when you do that you get a times b, which is 9 in this case, or 3 squared, and then the next line you have 2 times 3, and then you get 6. So you can see that there are a few ways that you could get the same answer. However, it depends on the numbers that you are given. Sometimes it's just easy to go ahead with this depending on the number that you have. However, alternatively, what you could do, you could try to simplify them and times them at the end, right? I hope this makes sense, guys. Like, share, comment, and remember to subscribe to our channel for more videos. Thank you so much. I will see you soon. Yeah, true, Marisa.